Hey everyone, welcome to BrainFlux. In this video, we're going to go through a vector problem. So this problem has two vectors, A and B. Vector A is 60 degrees from the positive x-axis and it is 10 units. And then for vector B, it is along the negative x-axis and it is 5 units long. So let's just get a visual representation of that. Okay, now what they're asking us is to find A plus B. So that means that combining A and B. So we're going to use something which is called the parallelogram law. Some people would choose the coplanar method, but in this case, we're just going to use the parallelogram law. But if you want to know how to use the coplanar or how to break it down into its components and then resolve the resultant vector, I have that on my WhatsApp channel. It's kind of just like a solved solution of the same question now using that method. Now let's continue, and in order for us to do that, we need to draw what are called equal vectors. Equal vectors are parallel to a vector and now of the same magnitude. So if we have vector A here, and then we draw another line which is parallel to vector A just like that, and then it's supposed to have the same length, as well as for vector B. Also do the exact same thing. So we see that they meet at this point. So now we need to draw a diagonal from the origin up to the point where these two equal vectors were extended. So they meet there. So that's the diagonal. So that's our resultant vector. So now we need to find the length of that vector using trigonometry. Okay. So now how are we going to do that? If we use the cosine rule, the cosine rule is used when you have two sides and the angle in between. But in this case, we only have the two sides without the angle. So let's try to find what that angle is. So remember, B was along the x-axis. So this means that its equivalent vector here is also parallel to the x-axis. So since we have two parallel lines and we have a diagonal, also called the transversal, that means that the angle here is equal to the angle there. So that's also a 60 right there. So since we have that 60, we can now use the cosine rule. So that's the general expression for the cosine rule. If you're not familiar with it, you can just pin a comment saying trigonometry and I'll make a video on that. Okay, so now let's get into the problem solving. So if you look at that A plus B, it's kind of like in two straight lines. So that just means the modulus, aka the length of that line. So that's equal to the square root of A squared plus B squared minus 2AB cosine of R. So I deliberately used small letter A to represent the length of vector A and small letter B to represent the length of vector B. And that cos R just means that the angle that is opposite to the resultant, aka the modulus of A plus B. So now let's just replace those values. A squared is 10 squared plus 5 squared minus 2, 10 multiplied by 5 cosine of 60. So if we square 10 and 5 and then add them, that's giving us 125. Multiply 2 by 10, then by 5, that's giving us 100. The cosine of 60 is 0.5 or 1 over 2. So finding the half of 100 is 50. So that's 125 minus 50, which is 75. If you plug that into a calculator, well, it's approximately giving us 8.66 units. So that is the modulus or the length of A plus B. But remember, vectors have both magnitude and direction. So here, since we were asked to find the sum of A and B, we also need to find the direction. So we're going to give the direction with respect to the positive x-axis. So what's the angle from the x-axis to the point where we're having our resultant vector? So if we look at that very carefully, we have something like a 60 degrees there. But if we would just find the angle between vector A and the resultant vector, you see that, right? We would just add that 60 plus that angle and we would have that direction or that angular displacement. So now how are we going to do that? Okay, we need to use a bit more of trigonometry. So now we want to find the angle which is here, right? So we ask ourselves what side is opposite to that angle. This is a 5. So we utilize what is called the sine rule, and we just find, pairs, angle opposite side, just like that. So now if we look at what we have right now, we have the side which is opposite to this 60-degree angle, and that's equal to 8.66025 as we've calculated, and then we also have the 60 degrees there. So we're going to write that as r over sine of r. The capital letter represents the angle, the small letter represents the side. I'm using r to show resultant. Yeah. So now, if we look at the other thing that we want to find this angle here, which is opposite to vector b. So we're going to use b over sine of b. So what we want to achieve, we just want to find the angle b. So here we need to cross multiply. So that's going to be, then we have 8.66025 times sine b. Then we're going to divide both sides by 8.66025, and we have this expression right here. I'm not going to really punch it directly. The only thing that I'm concerned with is how to get rid of the sign, which is connected to b. So when this sign crosses the equal sign, when the sign crosses the equal sign, yeah, it's going to become arc sine or sine inverse. So now when you plug this into a calculator, the sine inverse or whatever value you're going to find here, that's giving me 30 degrees. Okay, so that means this angle here is 30, this angle there was 60. So the total angular displacement from the positive x-axis is 90 degrees. So which also shows that we didn't draw the diagram correctly. But anyway, doesn't matter. So here we're going to state it as 8.66 units, and it's 90 degrees from the positive x-axis. So that's how we find the sum of vector A and vector B. Now let's move on and let's find the difference between A and B. So if we look at this, it's A minus B. Vectors are very case sensitive in terms of direction. So if we have a positive vector moving in one side, it means that the negative vector will move in the opposite direction. So if we look at B, B was along the negative x-axis, but now since it's negative B, it's supposed to be along the positive x-axis. Okay, now taking this into consideration, we draw equal vectors, an equal vector for A and an equal vector for B. Then we just connect the diagonals. So connecting these would result in this line, which is going to be the resultant. Okay, honestly speaking, we can get rid of this other part. We just need to have a triangle because vectors are added from head to tail, just like that. So this is our resultant vector. Now let us find its magnitude. So the magnitude of A minus B, we use the cosine rule, just as we did for A plus B, and that's going to give us 10 squared plus 5 squared, right? And then that's going to be minus 10 times 5. Now wait, hold up. Remember, we got these two lengths, this 10 and this 5. So what we need to do, we need to find the angle in between those two. Now, how are we going to do that? So remember, this 5 units up here is parallel to the x-axis. So we already determined that the angle here is 60. So that means that this entire straight line is equal to 180. So that's 180 minus 60, which is going to give us a 120. So the angle right here is a 120 degrees. So we plug in cosine of 120. Okay, now let's multiply. So 10 squared plus 5 squared is going to be 125. 2 times 10 times 5, that's 100. Cosine of 120 is negative 0.5. So that's going to be negative 100 multiplied by negative 0.5, which is going to give us positive 50. So that's going to be 125 plus a 50, which is going to give us the root of 175. Plug that into a calculator and we'll have approximately 13.23 units as the magnitude of A minus B. Now let's find the angle with respect to the positive x-axis. So in order for us to do that, we need to utilize the sine rule. If we look at this very carefully, we already saw that the angle from here to there is 60. So if we just find this angle within the triangle and then subtract it from 60, we will find the displacement of the vector with respect to the x-axis. Okay, now how are we going to find that angle there? So first of all, we need to look for an angle and a side pair that are already been given. So that's 120 and the ara, right? The resultant. So we're just going to say ara over sine ara. Okay, now we need to determine what we want. We want to find this angle right here. So this angle is opposite to vector b. So we're going to say b over sine of b. Let's make it a bit more rectangular. Okay, let's just cross multiply. So that's r sine b is equal to b sine of r. Okay, let's just make sine b the subject of the formula. So we need to divide both sides by r. So that's going to give us sine b is equal to. Okay, now let's just replace the values. B is 5 units. Sine of r, that's going to be 120 over the length of the resultant vector, which is 13.2288, and that's correct to 4 decimal places. Now let's just make let's get rid of this sine which is connected to our b. So that's going to give us arcsine. B is equal to arcsine or sine inverse of this expression right here that I will not punch. You can do that on your calculator. So this is going to give us something close to 19.1 degrees. So this is 19.1 degrees right there. Now what we need to do, we need to subtract. We say 60 minus 19.1 degrees, right? So in the end, that's going to give us something close to 40.9 degrees. Okay, so that means that the resultant vector is 13.23 units at an angle of 40.9 degrees from the positive x-axis. And that's how we find the resultants of vectors. Well, this is the end of the video. Make sure to subscribe to the channel, smash that like button, and also hit that notification bell so that you don't miss out on any other content. Till next time, success through synergy.